Now we talk about the Coanda effect used in the last 2 years in Formula One to overtake the reason that the FIA changed the regulation and the exhaust need to be shortest and higher, then it's not possible to go on the top of the rear surface of the car. Then between the two rear wheels. Then if we take now the plow again, and now I will take this rigidly fixed in my hand, I will show how the plow will change the direction. You see? Now the direction, see how much is affected the direction. The plow remain attached to the surface, and if I will working with that, I will try to find the best, I think, the best deflection angle between this direction, vertical one, and that direction that will be the tangent of this part. The reason that is not very fine is because this needs to be a flat face instead to go so round. But it's the same because we can see the deflection there. Now the question is, FIA, originally the exhaust was at the position of the ground, of the rear part of the car. But after they decide that the exhaust needs to be at some height and some distance, if we think that the exhaust is living at this position, and this is exhaust living with this direction parallel to the top part of the surface between the two wheels of the rear car. Then now what we need is to try to send this air down on the drawings. After I will explain why. But then I need to bend that plow, and you see that is this distance now. But if I work with that, I can deflect the plow. Here is possible to say. I have deflected the plow till the top part of the rear surface of the car between the rear two wheels. Then now this direction of the plow was converted to that direction that I need. Now I explain with drawings why we need that effect. The bodywork is coming with one shape, practically like this, and here is the diffuser, and that is the side wall of the diffuser. Will be that and that wall. Then will be inside view, we will see this part, and this will be the diffuser angle, that is that. The important thing is with the exhaust, what they found is when we have the exhaust coming from the engine, and then going till 2 years ago was coming here, going through this part and practically blowing in this direction. Then blowing here, what happened was expanding between the rear wheel. Then we see if this is the rear wheel. Ground, and we have the diffuser here. And here is the structure, rear structure, and the car was coming like this. And this is the side pods till the maximum position that is permitted by the regulation. These are the fins. And what was found that blowing exhaust here, that will be the exhaust there, and this is the ground, will generate one pneumatic skirt, inducing air circulating at very high speed here, inducing that the air coming from the bottom part of the car coming with higher speed in this sense, moving below the car increasing the speed of the velocity vector when it's leaving the car. This generates higher the speed, then higher is the negative pressure that will be generating the rear diffuser. Then now the question is, in one moment this was solved after 2 years working, they solved. But last year and this year, this is not permitted anymore because FIA established that the exhaust will have at some distance from the rear wing and will have some height from the bottom part of the car. Therefore, this exhaust, if we leave completely free, is going in that direction. It's what I show when we have, for example, the tap here, the water coming here, the flow of the water coming here, and I put this little flat plate, and we see that the exhaust is coming here. We need to come here because we need to put this flow there, as was the exhaust before. And then we need to find a way to bend the direction of this air and this flow to go on top of that. That will be on top of this phase. This phase will be that, if we put in this sense. And then for some effect a long time ago, using that effect in planes to deflect the air, and what happened all there is deflecting on curved shapes. Then it's creating the what is the Coanda effect. And what Coanda effect is, if each time that we have a curvature, we have a a flow coming with a velocity in that direction, we have always that the flow working on the surface is generating a variation of speed with the proximity to the surface. At touching the surface, V is 0. Here is the velocity of the air, we call infinite, that will be completely far out from the surface. But when this arrive at 25%, with this velocity here, V1, arrive at 21%, we call boundary layer. And this is called boundary layer, where is going, the speed will be going 0 for each layer of air, and then growing till 95% of the 100% of the real speed, or the infinite speed that we call. Therefore, if we have here one air coming, the boundary layer will be like this, in the straight part. But because here is 0, and here we have a vector velocity, and here V0 is 0, and V maximum on the boundary layer is one value x, then we have that this will create a moment, because if the boundary layer is attached, then will not be any problem, and the boundary layer will be going with the curve. And then the boundary layer will be something like this. But if the gradient of this curvature and is going more than one value, what happens is we start having a reverse flow in this sense, and then the flow start going in that direction. Then that is what starts separating here, and that is what called the boundary layer separation, and turbulent flow is created in this area. Therefore, this is a big work to try to develop this shape, and that is what working very hard in all the Formula 1 teams, to try to have the better shape on the side pod, on the rear part of the side pod, to maintain the air attached with not separation, to follow not attached separation. That is the reason that they start going with shapes like this, going higher on the back to try to keep maintaining the boundary layer, because if not, we'll be separating this part and doesn't work anymore. Now, if we add here that we need to have the exhaust in this position, and the exhaust will be blowing in that direction, and we want that the flow of the exhaust go in that go here. The question is how to deflect that, and this is coming from this very easy example with a very easy we say home experiment. Then we saw that we could move the flow from there to there. Then what we need to do is to create a shape here that will have this shape here, and then the flow will go here attached. Then we create a new boundary layer. That is a reason that most of the car on the side pods, when it's coming on the side, if this is the part on the car, they cut this part like this. Here the exhaust is there, and they give this shape that flow there in that direction, touch the ground there, or the ground, the surface on the chassis. This will be the ground, really. This is the top part of the surface of the car. Bend in that direction. They put some plate here to eliminate for the lateral flow coming, not affecting this flow and not changing the direction. And then the flow will be going like this, will be going here, and will be going exactly between the wheel and the side wall of the diffuser, then reproducing exactly a same flow circulation without a pipe. And that is the Coanda effect. You can do it in aircraft. Has its designing some aircraft that to generate, they put the turbine here, and then here is a plane. The wing, and after they have the flaps here, and then coming that the flow go like this, and it's practically creating a big vertical force for the flexion of the exhaust of the turbines. And this is what called a Coanda effect. It's something that came from many years ago in aeronautics. We are talking before year 1930, 1920. But was last 2 years ago was applied for first time in the Sauber Formula 1 cars, and was so effective that everybody used it.